What comes to your mind when you think about generative AI or large language models? Do you think about training your models or using them? I believe most of you would agree that the answer is it depends on whom I'm asking. I attended a session 6 years ago on AI when working with AI was more about creating our own models. The title of the talk was You Do Not Need to Build a Washing Machine to Wash Your Clothes. Of course, the takeaway was please use the existing models. And I believe with the existing powerful LLMs that we have now, a lot could be done with them. So, what are the possibilities? Chatbots, better recommendations in your applications. But wait, do you understand the basics that would help you to determine the capabilities and limitations of what you could do with generative AI? And how does Spring AI fit into all of these? Those are good questions, but I don't have answers to them. Don't worry, our speaker today most probably does. Hi everyone, thanks for joining in for another IntelliJ ID live stream. I'm your host Mala Gupta, and now let me add our speaker to the stream. Hey
Hello,
Dan.
Mala. How's it going? Good morning.
Oh, it's going good. It's a pleasure to have you present with us today. Thank you so much for accepting our
Uh,
invitation.
I'm really excited to be here and really excited about the topic that we have today around AI. So it's going to be a lot of fun.
And absolutely a very relevant topic. I know most of the folks watching Dan would know who he is, but just to some little count that we have out there who don't know who you are, let me quickly introduce you, a fellow Java champion, Spring developer advocate. Dan is an amazing presenter, and he recently hit 50K on his YouTube. Many congratulations to that for that.
Thank you so much. Yeah, it's been a pretty big year for me. I'm really excited about that. I'm also a little nervous that I may have hit my stride. So we'll see.
All the best to you. And before Dan, I let you take the stage, I have a quick question for you.
All right.
Could you share some of the use cases that folks could use for that folks would use Spring AI for?
Mala, that's a lot of what I'm going to cover today, but just at a high level, yeah, just introducing generative AI into your applications, being able to bring your own data and augment the LLMs that are out there. So yeah, we'll go through a couple of those use cases today, and even when we get into some demos, we'll take a look at those.
And when is the Spring AI going GA?
Yeah, so right now it's version 0.8.1. It is, if you go look at calendar.spring.io, this is our release calendar. This kind of shows you what's happening in our ecosystem when projects are releasing. It says May
Mm,
15th, a few days before Spring Boot 3.3.0. So I'm going to say May
mm,
15th, but that calendar, it's not set in stone. So I'm going to leave it at that.
mm. I understand. No more questions. But before I let you take the stage, let me share some quick housekeeping details with everyone who's watching. Please use YouTube chat to post your questions. We'll try to answer your questions as you post them. Dan would take quick breaks during his session to answer your questions. We also have Roman from the JetBrains team who would be answering your questions. And yes, the most important question, this session is being recorded and will be hosted on IntelliJ Ideas YouTube channel and also JetBrains Twitch channel. So if you haven't already subscribed to our channels, now is the time to do so. And if you like today's session, which I hope you will, do not forget to like the video. Now, with that, Dan, let me add your slides to the stream. If you could make them full screen, that would
All
be
right,
great.
here we go.
Yes, perfect. Now I'll
All
be
right.
backstage and have fun.
All right. Thanks again, Mala. I see a lot of my friends here in the chat. So thank you guys for showing up. If you have questions, go ahead and get them in. We'll find some kind of stopping points to kind of answer some questions. But today is going to be a lot of fun. Spring into AI, building intelligent applications with Spring AI. As Mala said, my name is Dan Vega. I'm a Spring developer advocate at Broadcom. And this is going to be a lot of fun for me. This is a subject that I am very much interested in. So I'm going to have a lot of fun today. I'm interested in AI. I'm obviously interested in everything Spring. So we're going to talk about that. Real quick, I want to talk about my friends at DevNexus. If you don't know, This is coming up soon, April 9th through the 11th in Atlanta, Georgia. If you haven't got tickets yet, I have a discount code for you today. We love spring. What a great discount code. Thank you for that, Vincent. Go ahead and use this. There's a couple talks I'm really interested in. Enhancing software design with Spring Modulate by my friend Deshaun. And there's a workshop on Spring Boot 3 by Mr. Scott Fredericks. So that is going to be a lot of fun. So again, we love spring. Go ahead and use that discount code. A little bit about me. I'm a husband and a father. Is my beautiful wife, Jen, my two daughters, Isabella and Juliana. We live outside of Cleveland. As Mala mentioned, I was named a Java champion this year. It's been a great year so far. Really excited about that. I've been doing this for a long time. I hate putting this number up there because it reminds me how long I've been doing it. I've worn many hats in this industry, worked with many languages and frameworks. Really, a lot has been spent on the JVM in that 23 years. But one of my favorite hats that I've worn has been a Spring Developer Advocate. And the reason for that is I've been wearing this hat long before someone was paying me to do so. I've been a fan of Java. I've been a fan of Spring. So I'm happy that I get to do this in an official capacity now. I enjoy creating content. You can find out more about me at danvega.dev. I'm on the Bird app, X. I'm never going to call it X. So it's Twitter for me, at the real Dan Vega. I enjoy a little running and golf when I'm not doing this computer stuff. I have a show to tell you about real quick, Spring Office Hours. This is a podcast. It's a live stream that we do every Monday from 1 p.m. Eastern. This is a place to kind of get caught up with everything in the Spring ecosystem, as well as answer your questions. We turn it into a podcast that you can get on the very next day. So check out springofficehours.io. So what are we going to cover today? I want to do a little bit of a refresher with what is AI. I hear a lot of these terms when I get into new spaces, especially in the AI space. All these different terms are thrown at me, and I don't think until we kind of understand them at a high level, it's hard to dive a little bit deeper. So I want to kind of level set there. We'll quickly talk on Java and AI. What are we talking about here? This isn't AI like a Python thing. Why are we talking about it in Java? And then we'll dive into the project Spring AI. How do we get started with it? Kind of the foundations of Spring AI are being able to work with models, things called prompts, output parsers, and the ability to bring your own data. So let's start with what is artificial intelligence. I think we can all agree that we're a little bit inundated with AI these days, right? It's everywhere, but what is it? So let's talk about a few of the key terms. And the first term we need to discuss is AI, right? Artificial intelligence is a scientific discipline that's been with us since just after the Second World War. And for a long time, there was very little progress in this area. So what are we talking about when it comes to artificial intelligence? Now, this is a broad discipline that encompasses a wide range of different techniques. And I want to focus on just kind of a subset of those today, starting with machine learning, right? Deep learning is a subset of machine learning that involves the use of neural networks. So we're going to dive into what machine learning is, what deep learning is in just a little bit. Inside of deep learning, we have something called discriminative, and these are conditional models, and these are used for supervised learning. When we talk about supervised learning, it means, hey, they will do literally, they do what they literally say, separating data points into different classes and learning the boundaries using probability estimates and basically like a maximum likelihood. So we have this one side of deep learning. Then we have this other side with LLMs and generative AI. Generative AI is kind of all the rage these days. These are the things we're talking about with things like ChatGPT. This is based on a transformer architecture, which is able to take the training data that the machine learning system has and generate something brand new. Whereas on the other side, discriminative is just using the data that it has to work with and generating some probability. So right in the middle of LLMs and generative AI are the things that we're used to seeing these days, right? Like ChatGPT from OpenAI, Google Gemini. There's a lot of other LLMs out there that kind of do what they do, but these are two of the bigger ones that you'll hear of. So we're going to spend a lot of time right in that area. But I want to kind of talk about those things that we just covered. So like many of the names in the field of AI, the term machine learning isn't that helpful, right? It suggests that we could just put a machine in a room with a bunch of books and have it learn on its own. While that seems like science fiction and maybe one day possible, we know that's not the case these days, right? So I think a really good place to start is to learn a little bit about what machine learning is. Like what is it exactly? Machine learning is used, we use machine learning to take data and train a model, right? So we have this training data, we train a model, and then that model can go ahead and make predictions based on the data that it's never seen before. So I think to understand this a little bit more, it's good to look at some use cases of what machine learning is out there doing in the world today. So one of the big use cases for machine learning is facial recognition. You'll be able to look at a face, feed it a bunch of data about different, about people, and then be able to recognize different patterns in those facial recognitions. You can go ahead and recognize tumors on X-ray scans. So we can feed it a bunch of X-ray scans. A doctor no longer needs to manually look at every one of these. We can kind of notice those or get find out about those early on. Same thing with abnormalities on ultrasounds. Again, you're feeding this data into a system, it can kind of notice those. If anybody's got a Tesla, self-driving mode, being able to recognize a stop sign or if something's a pedestrian, that is machine learning. Again, we're feeding it lots of data and it's starting to recognize patterns. Another one is like fraud detection. The financial industry looks at a sample size of data and sees what patterns it can recognize as far as like what are real cases and what are fraudulent cases. And based on that, now it can get a new set of data and kind of determine if something is going to be fraud or not. We use machine learning every day. If you're on YouTube watching this right now, maybe you got a recommendation to watch this. That is machine learning. And things like spam filtering. Another one that I heard recently on a podcast that was really cool is that all NBA practices, I won't say all, I'll say for this particular team, NBA practices are all recorded in their facility, right? And they have like a number of cameras pointing at all the players. And in a practice facility, there's like, it's not just 2 hoops, there's probably like 12, 14 hoops, whatever. And the players can go through and like shoot on the hoops, and these cameras will pick them up through facial recognition and then start to record all of their progress. So when you're done with practice, you come in and you go, okay, you shot 10 threes today and made 8. You shot 100 free throws today and made 90. And so now as a player, you get all these statistics on what you did in practice without having to keep them yourself. So I thought that was a really cool kind of case of machine learning and facial recognition. So again, when it comes to machine learning, it's all about supervised learning, right? We are labeling the training data. The easiest way to get a machine to do something is by giving it a label. So we give it an input. In this case, I'm saying, here is a picture of me. When I show you a picture of me, I expect the output to be Dan Vega. And I give you another picture and I give you another picture. And if I give you enough of this data and then show you a picture that you've never seen before, here's what I expect the output to be. And we just keep doing this. We feed the system a bunch of pictures with the text and what we want it to respond with. So if you've ever been on like Facebook or Instagram, you're doing this for big companies. So if you had a bunch of pictures come in and you label it, hey, I was at a conference with Dan, you are providing the training data to the machine learning algorithms of these big data companies. So I know we all knew that, but just to put it in perspective, you are helping with supervised learning for companies like Meta. Okay, so that's machine learning at a high level, but how does this work? So if you remember back to my diagram of the machine learning, there was a subset of that called deep learning. I don't want to get real technical with this, one, because I am not an expert on it. So there's going to be a little hand waving here. But if you do want to learn a little bit more about this, I put some links in the resources, which you'll see at the end of this presentation. So if you look at a human or an animal brain, you'll see that it contains enormous amounts of nerve cells called neurons. And these nerve cells are connected to one another in vast networks called neural networks. The human brain has something like 86 billion of them. I mean, that's like mind-boggling, right? But what do we care about that? Well, how can this work in machine learning? it turns out that this is something that we've been trying to solve for a while. It's like, how can we implement these neural networks in software? And that is what deep learning is. Deep learning is a subset of machine learning that involves algorithms and models that mimic the structure and function of the human brain, known as artificial neural networks. So at a real high level, that's what neural networks are doing artificially. The idea of building this computer network has been around since the 40s. It was really only this century that this kind of became possible. And it really became possible because of these three things. Scientific advances in deep learning, the availability of big data. The data that we have collected this century has not always been around. And it turns out that you need a bunch of data to configure these neural networks. And the last thing is lots of computer power. It takes a lot of compute power to train and configure these networks. So those were the ingredients that really started to make AI possible this century. Getting the big data, lots of compute power, constantly training, constantly adjusting the neural network. And that really happened kind of early this century. Turns out there was something else that came along that really helped us out here. And that was a particular type of computer processor that is really good at doing all the mathematics to build these neural networks. And again, you need a lot of compute power to do this. This all got supercharged by the graphics processor, the GPU. So the availability of big data combined with the compute power and the GPU really started to move us forward. Probably in around 2012, this really started to pick up. So last one, and then we'll kind of dive into some of the Java and Spring stuff. So where does that take us? We have machine learning, we have this deep learning. It starts to become clear after we get this compute power that bigger is better. More data, more processing power, bigger is better. And around 2017, we really started to see a flurry of AI applications coming into this space. And what launched this was probably one of the most important papers on AI in the last decade, which is called Attention is All You Need. And if you look at the A and you look at the I, those are capitalized pretty cleverly there. So AI is all you need. But this came out of Google Brain, out of their research lab. You could see there's 7 folks listed on here. I think all of them went on to start their own AI companies and are no longer with Google. But this technology was designed for something called large language models. It was really the structure, this paper, the ideas behind it. It was this structure that made LLMs possible. And what made this possible was something called the transformer architecture. It was a specialized architecture for token prediction, which is, a novel way to look up words in a sentence, assign weights to words, parallelism, being able to predict the next thing that is coming. One of the key innovations here was attention mechanisms. Again, this paper is out there. If you want to go through and read it, you can. I have not. I went through a few pages just to kind of get the gist of it. You can also ask ChatGPT to give you a summarization of that paper, and you'll get a good one. So yeah, it's not just a big neural network. It is this transformer architecture that really kind of started up the wave of big LLMs. So what are large language models? Again, a large language model is a type of artificial intelligence that can generate text, understand language, answer questions, and more. So we've probably all dealt with something like ChatGPT, so you're kind of familiar with that already, but that's an LLM. They are large because they have a vast number of parameters, which are parts of the model that are learned from data during training. So LLM is not just a search tool. If it was just searching, that would, we have those tools already. It's important to note that it's a text pattern recognizer and probabilistic text completion tool. We'll talk more about that in a second. But again, the idea. You ask it to complete. you then ask it to complete the most probable text, giving a starting point, which is the prompt or the message that you give it, right? So that came around in 2017, the transformer architecture. What happened next was, in 2020, we were all sitting around in our houses during the pandemic, And this company called OpenAI came out with, it launched something called GPT-3. And this was huge. So it had 175 billion parameters. The training data that it had was hundreds and billions of words. So if you think of something like 500 billion words, that if as a human you were to start reading 1,000 words an hour, it would take you over 1,000 years to get to that. So it's just mind-boggling the amount of data that these systems have. So LLMs, there's a bunch of them out there. We know of things like GPT and Gemini, but if you go to huggingface.co/models, there's a list of all the models out there. There are some open source models. There are some closed. If you look at that list up there, that number says 570,761 models. I'm not sure they're all up to date or all that, but there's a lot out there. So if you're interested in checking out different models, this is a really good place to go. Okay, so that brings us to what we're here to talk about today, which is generative AI. So the GPT, the reason I wanted to cover some of those terms before is so we could understand what we're talking about, right? Generative. We want to be able to generate new content, whether it's text, speech, images, etc. Pre-trained. We now understand that like these machine learning systems are pre-trained. The LLM from that is pre-trained on a huge, vast amount of data. Not only that, but like, how do you pre-train a system like that on all that data, right? You have to go scrape a page, find all the text, follow all the links on that page, and do that for the entire internet. Just think about how expensive it is to train these LLMs. Just a basic cost of electricity alone to run these supercomputers is probably astronomical, right? So one of the implications here is that not anyone can create a large language model. Again, there are some open source ones that you can tweak, but this is why you see a lot of the big tech companies creating these. The Googles, the OpenAIs that's funded by Microsoft. Grok is out there from X. So this is why like it costs a lot of money to build these really large LLMs. So that's generative AI. Again, unlike the facial recognition that we saw earlier, we can take the training data that we fed into this machine and generate something completely new. So if we're talking like, is this machine learning or is this generative AI? If we get out a number, if we get out a classification, like this is Dan or this is Joe, if we get out a probability, we can look at a bunch of data and then probably figure out that this financial case was fraud. That's not generative AI. What is generative AI is being able to process natural language like text or speech, being able to generate new images, generate new audio. So I think that's a good stopping point. I just want to check with you, Mala. Do we have any questions so far as kind of the intro stuff?
We have loads of them. You
Oh.
need to brace yourself.
All right.
Okay, so I'll take just 2 or 3 because I know you have to cover a lot. So this was, I think you would see a lot of this question: what knowledge must we accumulate to avoid being overtaken by AI in the next 10 years?
Yeah. So the more that I've gotten to understand these large language models and like how they work, like I know everybody fears that like AGI is right around the corner. I don't see it that way. Like I feel like that's a long ways away. I'm no expert in this, but I would say this is what I said. Everybody asks me, like, are you afraid that AI is going to take your job? And I think that's what the most of the public is talking about. Like, I don't want my job taken away. And I always think of these things. I think of AI as a tool in my tool belt now. I am not scared of it. I am using it to get better at my job, to get more productive at my job. And I think it's just one of those things that you gotta, as programmers, we are constantly learning new things, staying up to date, and you just have to adjust. If this is just a tool now, fine. If it becomes a bigger tool in 5 years, then learn how to adjust and make yourself useful. But there are certain CEOs out there that are walking around telling you like programming is dead. There's these tools like Devin that come out here that are like, okay, programming's like a dying language. I don't believe that for 1 second. Programming is going nowhere. Maybe like some low level data entry, but right now it's just a tool in my tool belt, and I'm way more excited than I am scared of it.
Absolutely. Knowing what it can do and what it cannot do, that would be a
Yep.
big factor in answering these questions. So a lot of folks, they kind of agreed with. So we have a compliment that you started. It's great that you started with
Awesome.
terminology.
Yep.
And so there were other folks who were answering questions, the ones that was asked earlier. And yes, so this one question, if you want to take that later, you could do that. So Tim asked, we're using regular REST API calls to call LLM AI models. I'm hoping to hear a compare and contrast. So I
Yep.
think you would be doing
I'm
that
going to
later
jump
in the session.
right in. Actually, I'm going to jump right into that now. So that's a good
That's
question.
amazing. Yeah. So,
Yep.
Tim, the question is being answered. So, I'll let you move forward with your session.
Okay.
If you could maximize your
Yep.
slides, that would be great. Okay. So, I'll be
All right.
backstage.
Cool. Thanks, Ma. Okay. So we got some terminology out of the way. We understand some things. I think so. An obvious next question is, what is Java's role in this? I'm a Java developer. I'm a Spring developer. Why are we here talking about it? Because for the longest time, right, we've heard of machine learning, deep learning. This whole space was basically covered by Python. And there's a reason for that. Python is a really great set of tools for data science, machine learning, deep learning. But as Mala pointed out in the very beginning of this session, there is a big difference between training these models and actually using these models. And so I think now that we understand some of the terms we were talking about, we can kind of draw a distinction, right? We are not working for OpenAI. We are not training this massive large language model. We want to be consumers of it. We want to be able to use it in our applications. And so let's talk about that. So when it comes to Java and AI, how can we leverage AI? First off, why AI in Java? Well, AI is becoming ubiquitous across the IT landscape, right? You cannot go anywhere without hearing about AI. You're probably at your job, at your corporation, your managers, the higher ups, they're probably starting to, probably have been doing this for a year or two now, saying, how can we incorporate AI into our applications? Because if you could start saying our this app is AI powered, it all becomes that much more intriguing. Java is the language of the enterprise. We know this. Everybody says Java's been dying for 28 years, right? But we know that's not the case. Java is used across the world. It's huge in the enterprise space. And creating AI apps in Java is now a new requirement. Like, we all need to be doing this. So Spring AI is going to come along. We'll talk more about Spring AI in a little bit. I like this, kind of liken this to Spring Data. So we know that we can write Java apps. We can connect to a database in Java. We don't need Spring to do that. But Spring gives us these different layers of abstraction on top of that to make everything so much more easier, right? So Spring AI is going to provide the necessary API access and all of these components for developing AI apps. And we're going to talk about this. So Mala asked me the question at the beginning, what are some different use cases? So what if we want to go ahead and feed this system a whole bunch of documentation and be able to provide quick Q&A for anyone visiting our application? Maybe we have a whole bunch of documentation and we need summarizations of those. Maybe we need to generate new text, new code, image, audio, video generation. So there's a whole bunch of use cases for this, and this is kind of growing as we go. Now, I got a question before. We saw that OpenAI has this large language model called GPT, right? So why I could just call that with a REST API, right? Because they make it available via REST API. Sure. So I just have a batch script. I'm not even using Java at this point. I'm just saying, hey, here's my open API key. Here's the prompt. And I make a curl request. And I'm saying, hey, the content type is application JSON. Here is my authorization. I define the model. So you can go look at the open API docs for their REST API, just like any other REST API docs that you've looked at before. It asks for a couple of parameters. One is the model. I'm using GPT-3.5 Turbo. So OpenAI has a bunch of different models. And then the message. I'm sending a user message. We'll talk more about that in a minute. But I'm sending a user message to say, hey, when was the first version of Java released? So this is just a bash script. I run this on my machine and I get an answer. If you look down there, there's a whole bunch of data, one of which is content. The first version of Java was released on January 23rd, 1996. I think is that the version 1 or the first version? I think that's version 1. So yes, you can just call OpenAI. You can just call Google Gemini with a REST API and be done with it. So you can do that in Java without Spring. But as we're going to learn, Spring AI provides us so much more than just a facility for making REST calls. Because if it was just a REST call, then we wouldn't have a need for an abstraction on top of that. So what is Spring AI? Spring AI is AI for Spring developers. This is a new project. It was in an experimental status. It is now out of that. It's in the under the official Spring Projects umbrella. This was started by Mark Polk. He is the team lead for this. He's done a lot of really good presentations on Spring AI. So if you get a chance, check his out. Again, I mentioned this earlier. The current version is 0.8.1. You can learn more at spring.io/projects Spring AI. So there's like a nice overview. You can go in and read through the reference documentation. Anytime you're trying to learn a new Spring project, I always recommend start with the documentation. We are lucky to have some really great projects with amazing documentation. This was inspired by Python projects like LangChain or Llama Index. When this project was starting, Mark said he went out and took some of the good things from the Python projects that were out there, and really kind of turned them into the things that we're used to working with in Java and Spring. So it aligns with the Spring project design values. So things like component abstractions, default implementations if you don't set something up. Here's what's really important: portable chat completion and embedding clients. This means that if I'm working with some code and I need to get some chat completion, and I'm just testing out OpenAI's GPT-4 today, that tomorrow I can go use Google Gemini using the same code. I kind of just switch some parameters around, but it's the same code. And that's that portable chat completion. We got multimodality support, so being able to work with chat or images or speech. We'll talk about vector stores as we get into this a little bit more. Being able to bring your own data, supply that to the LLMs. And when we get into Spring, kind of the key components are working with models, working with data, being able to chain and evaluation. So the Spring AI API covers a wide range of functionalities. I talked about this before, but chat model, hey, I'm going to give you some text, give me some text back, generate some new text, right? Text to image, I want to give you some text, give me an image back. Hey, I want a dog playing cards at a poker table. Give me an image back that looks like that. Transcription, be able to give it some audio and get some text back. So maybe I have a podcast and I want you to transcribe that for me. Can you do that? Embedding, this is where kind of providing your own data comes into play. And we'll talk more about this later, but this is, hey, I want to give you some PDFs. Embeddings are a way to kind of split those PDFs into documents and store those into a vector store, which is a specific type of database for storing these types of embeddings. But the nice thing is you get this portable API across all of those embeddings, across those vector databases. And finally, functions, something kind of new, basically a way to invoke your java.util.function to add functionality to the LLM. So I mentioned transcription too. I just want to make a side note here. Give me some, here's some audio, give me some text back. If you look in the 1.0 snapshot branch for Spring AI, this has text-to-speech support in it. So this is coming soon, being able to give it some text and turn it into some speech. Okay, so chat model, give me some text, give me some text, or give it some text back. These are all the different models that are supported. The big one, OpenAI, Azure OpenAI, Amazon Bedrock, Google Gemini. So these are all supported. I'm grabbing these right from the documentation. So check out the docs. If you want to do text to image, that is supported with OpenAI using DALL-E and the Stability API. So the Stability AI. So if you want to do some image stuff, I would suggest checking out the OpenAI one. Same with the transcription, and then embedding models. Like, hey, I want to be able to provide my own data to the LLM. Things like OpenAI, most of them are supported here. So that's kind of the high level of Spring AI. Let's get started. Let's build something with Spring AI. So before you had to go in and I'd say a few weeks ago, you had to go in and kind of configure it on your own. But now if you go to start.spring.io and go to the dependencies block there and you can pick one of the providers. So in this case, I'm saying I want to build a Spring AI application with support for ChatGPT, the AI language model, and DALL-E, the image generation model from OpenAI. So I can choose OpenAI right from there. Another way that you could do this is a really cool tool out there that I'm using more and more that I'm really excited about is the Spring CLI. This isn't the default CLI that's been around forever. This is a kind of new project as well. But if you go to spring.io projects, Spring CLI, you can learn more about this. But it really gives you a nice way to create new applications with code. And as opposed to the Spring Initializer, that is really a way to bootstrap data. This is a way to start a new project with some code or even add code to it later. So you can use AI generated code to add to it. So this is really exciting. So I did a quick example of that from the command line after I got it installed. I said Spring Boot new from AI. AI is like the template. Here's the name of my project. It creates a project with some code in it. I have a simple AI controller there ready to go. So those are two ways that you can get started. Again, I'm going to get started with OpenAI today. I think everybody's pretty familiar with it. But we do have a session coming up on Spring Office Hours on using Spring AI with Google Gemini. So we'll talk about that in a little bit as well. By the way, I don't know if you saw this. This is a screenshot from OpenAI introducing Sora, creating video from text. So that's another type of model. Spring AI doesn't support that yet because Sora is just not out there yet. It's very, very beta or alpha. But some of the things that it's done so far are really cool. And as a video content creator, I'm really excited about that. So once you go over to OpenAI, you need to create an API key. So we're going to create a key, which also means if you're going to create a key and you want to do this, you need to add some money to your account. Now, don't get too scared. We're going to talk about tokens. Like tokens are the currency of LLMs, right? And I know like we always get scared about like starting up a new like server on AWS because we don't want to be one of those people with the bill of like, $15,000 for not using it. But let's kind of back off and talk about this real quick. So if you go on OpenAI or Google Gemini, it will tell you their pricing. Now, OpenAI has different models. So there's like GPT 3.5, 3.5 Turbo, and GPT-4. And you can see what the input and the output costs. And again, tokens are the currency of LLMs. It says prices can be viewed in units of either 1 million or 1,000 tokens. You can think of tokens as pieces of words, not always just words, where 1,000 tokens is about 750 words. This paragraph is 35 tokens. So this doesn't cost a lot to get started with and just start working on your own machine. I've put in $10. I don't think I've used much of it in the last few months. But this is something you need to think about if this is an application you're going to put out in the wild and get a lot of throughput, because then, this could start to add up. I like a tool that they have too. If you go to platform.openai.com/tokenizer, you could put in some text. So I put in my like bio in there and it says, hey, this is 78 tokens. So I know exactly like what a token looks like. You could see the color coding down there, which I really like. So again, token is not just a word, but you can see how it breaks it down. So we've started our new application. We need to add a few parameters here. The first one is given to us by the Spring Initializer, but we need to say, OpenAI, here is the API key that we just generated. I need to put this in here. You can go ahead and put it in as just a raw string at first, but don't keep it there. I quickly moved to like an environment variable, so we're not having plain text in our code and accidentally committing this to like GitHub, right? Then you can give it the chat options model. So we saw that OpenAI has different models to work with. I'm saying, hey, I want to use GPT-4. There are a bunch of these options as far as like how you're going to configure this. These are the only two that I've done for today. But you'll want to go through the documentation and look at those and see if you want to kind of configure some of these, like temperature. This is like how creative the system is going to get, or things like max tokens. Like we saw tokens, but hey, I don't want you to send back more than this many tokens because I am conscious of billing when we get into production. So there's a bunch of properties you can set. Go ahead and check out the documentation for those. So with that, let's go ahead and do a demo. I'm going to jump into my IDE, which of course is IntelliJ, but even if I wasn't on this live stream, I would be using IntelliJ. So I have a quick application here, and I just want to show you that in my, let's go ahead and go into application.properties. You see I have my open API key. I have this as an environment variable. So it'll read from that, and I'm using GPT-4 just as I was in that screenshot. So I want to start with a simple chat controller. And we talked about this before as like having this portable chat client, this way to generate text, right? So if we look at chat client is an interface, and it has two methods in here. Call, which takes a message, so it just takes in a string, and then one that takes in a prompt. So we'll talk about prompts in a second, but there are two methods in here. If we look at the implementations of this, there is one for OpenAI chat client. So that's why when I go ahead and say private final chat client, and we ask Spring to inject this via constructor injection, OpenAI dependency is on the class path, and everything has been kind of auto-configured for me. I now have that OpenAI chat client here. So this is the mechanism that I'm going to use to contact OpenAI. So I have this method here. This is just a normal REST controller with a get mapping, and it says, hey, we're going to call /API/generate. This generate method is going to take a request param. It's going to have a simple default value. So if I don't pass anything, the message is going to be tell me a dad joke. And all we're going to do is use that chat client to call. So again, remember call, there is a call method that takes a string as an argument. So that's all we're going to do. And we're going to return a map back from that. So I'm going to go ahead and run my application. We're going to open up a terminal here in IntelliJ, and I'm going to call localhost 8080 /API/generate. So if we do that, I'm going to use HTTPIE, which is like curl for humans that can read stuff. Just makes it so much easier. So I'm going to say generate, and this is going to call it to OpenAI. And here is a joke. Why don't scientists trust atoms? Because they make up everything. Don't worry, we're going to do some more examples outside of jokes, but that is one. So I could easily pass in another message, but I'll just leave it at that for now. I have another one here that uses, actually don't want to get into prompts yet, but that is the gist of it. So that is very, at the basic level, what we can do. We have now kind of incorporated being able to take a message in our endpoint and then pass that off to OpenAI's LLM to go ahead and generate some text. So again, if we go ahead and let's try and run this one more time, we can just ask it for another joke. Hopefully we get another one back. Oh, we get the same one. I don't know why that's happening, but that's okay. So that's our simple use case. So I want to talk about kind of the next thing that we just saw, which is prompts. So we had a way to like input a message or a prompt. We're asking the LLM a question. There was those two different versions of the call method, one that takes in a string and one that takes in a prompt. For just testing things out, this simple use case of passing a string was great. But when we get into building real world applications, we're going to work with prompts a little bit more. So prompts serve as a foundation for the language-based inputs that guide an AI model to produce specific outputs. For those familiar with ChatGPT, a prompt might seem merely like the text that you put into that dialog box. However, it encompasses so much more than that. In many AI models, the text for the prompt is not just a simple string. We are really trying to guide these systems to give us our expected output. This has brought about the term prompt and engineering. I'm not a huge fan of this term. Really, what this comes down to for me is learning how to effectively communicate with the AI model. There are even job titles around prompt engineering. But it is, make no mistake, regardless of my feelings of the word, it is a very important part of building AI-powered applications to get out of them what you need. So this is inputting, directing the AI model to produce a specific output. Model outputs are greatly influenced by the prompt style and the wording. We talked about the term prompt engineering. There are some really great guidelines and courses out there. So OpenAI has its own guidelines. So when you're constructing a message to the AI system, here are some things you should adhere to. I really like those. There's also a really good course for ChatGPT prompt engineering for developers by Andrew Ng and I believe a coworker somebody at OpenAI. This is a really good course that I've gone through, really good to understand like how you should be writing these prompts. And again, so prompts and strings, we have prompt management relies on this text template engine. So we can think of this as Spring developers as analogous to the view in Spring MVC, right? If we were using something like Timely, we get some data, we put something into the model, and we can take that model and put it into the view. Similarly, we might have prompts, we might have templates in there, where we replace those template variables with like an actual value, and then we send it to the LLM. So here's an example of the prompt class. You can see that to create a new prompt, it has a bunch of different constructors here. One takes in a string, one takes in a message, one takes in a list of messages. But you also see that underneath the hood, even if it takes in a string, it creates something called a user message. What the heck is that? Why isn't it just a message? So if we look at the implementations of message, there are things like user message, system message, function message, and so on. And so what are these different messages? These are the different roles, and they vary across LLMs, but most of these are kind of this static and the same. But the user role, this represents the user's input, their question, their command, their statements to the AI. This is fundamental as it forms the basis of the AI's response. Now, the system role is kind of one above that. This really guides the AI's behavior and response style. So think about a user role where a user says, tell me a joke. At a system role level, you could say, you are a joke-telling machine, and all the jokes that you tell should be revolved around dad jokes. I don't want any other jokes on this planet, right? So the user is asking for a joke, but you can kind of guide it to be specific there. So we have these different roles. You can create a new user message on your own, or you can just create a new prompt, which will end up creating a user message underneath the hood. So here's an example of that. So I have a method here called find popular YouTubers that takes in a genre. This is using prompt templates, by the way. So now I can say, hey, I have this multi-line string. Give me 10 of the most popular YouTubers in whatever genre format, along with their current subscriber accounts. Here's the other cool thing. We're saying if you don't know the answer, just say, I don't know. This is an important part of this because hallucinations with LLMs are a real thing. It's not that it's out here trying to trick you. It's just that it's trying to put together its best guess based on all of the mathematics that are going on what it should say next. But if you say, I want you to make sure you don't know, if you don't know, tell me that. So with a prompt template, now I can pass in, we see new prompt template, I pass in the message, and then prompt template.create is basically replacing all of those templates in there. So I'm saying, hey, genre should be replaced with whatever the argument that came into this method is. So that is using prompts and prompt templates. And I think we'll take a look at a demo of that really quick. Okay, so let's go into prompt. And I think we had the simple prompt. So yeah, a simple prompt is, remember before we just passed in a string message. Now, instead of just a string message, you could pass in a new prompt. So we're not going to run this one, but I'm just showing the other side of that one. Let's go over to that YouTube one and look at that. So again, in this one, I'm doing the same thing in both of these methods. But all I'm doing in this one is I've hard-coded the string, the message right here in this method. So list 10 of the most popular YouTubers. I'm creating a new prompt template from this message. I'm replacing genre with the genre that comes into as an argument to this method. And then I'm calling the chat client's call method and saying, here's my prompt. So if you look at call, it returns a chat response. I could get that back, but at the end of the day, all I care about is the actual content. So I want to say, hey, give me the results, give me the output, give me the content. Now, this is great, but I can actually simplify this because I might want to reuse this in certain places, right? I might use this more than once. I don't want to hard code this in this method. So I can move this to a prompt template into a resource. So now on the class path, under prompts, I have something called youtube.st. And again, st stands for string template. It's been kind of built on some of the string template work. So if we go into prompts and I go into YouTube st, it's the same thing that we had there, but now we've kind of externalized that into a file, which I think is really great. Okay, I'm not going to run that one. I am going to run this dad jokes controller because this is the one that we saw before, right? So now I have two different messages here. I have a system message that says your primary function is to tell dad jokes. If someone asks you for any other type of joke, please tell them I only know dad jokes, right? So if I run this and say, tell me a joke, it's going to tell me a dad joke. But let's try and run this one where the user is saying, tell me a very serious joke about the earth. So let's see if we can rerun this. And this is going to be at /API/jokes. So let's clear this /API/jokes. And you see, I'm sorry, I can only tell dad jokes. Here's one about the earth. We don't ever live to tell secrets on earth because it might spill the beans. It's got too many faults. So yeah, still telling a dad joke, even though we asked for a serious joke. So then that's kind of the difference between like a system message, which is like overarching, and an individual user message. And that becomes very important as we start to like build out some of these more sophisticated applications. Okay, moving right along. So those are prompts. Output parsing. The challenge here is you basically get a string back. So the output of that generative LLM is a java.util string. Even if you ask for JSON, you're going to get a JSON string. So how can we turn that? Then we got to kind of do that marshalling of the JSON string into a type, because I'm in a Java app, I'm in a Spring app, I want to work with types. ChatGPT wants a chat. It doesn't want to reply in JSON. OpenAI has introduced a new feature to help with this, but Spring AI has a really nice feature called the output parser that allows us to get our desired results. The output parser is an interface. There are 3 implementations of this: the bean output parser, the map output parser, and the list output parser. So I'm going to quickly show you an example of the bean output parser. So if we go into output, and by the way, I don't think I've mentioned this before, github.com/danvega/springintoai. All this code is up on the GitHub repository. You can find it there. I'll make sure we get it in the show notes. So I have this book controller. And if I were to Oh, did I not have? Yeah, so I have a couple different ones in here, right? So my first method is I want to generate a list of books written by the author, and I want some by the author Craig Wells because he's an awesome author and he has got some really great things to say. So I want all the books that Craig has written. So I give it this prompt, I give it a prompt template, I create it, I get this back, right? This is nothing more than what we've been doing. But if we look at the results of that, it is just a string. It's just some JSON data. What if I wanted it to be in the form of a type? Well, I want a list of authors. And actually, I think I have an example of this in the README. Let's just jump into the README for a second. Because I'm running out of some time here. So if I were to go ahead and make a call to /Craig, my list, what the LLM is going to return is this. It's going to give me 1 through 9. I don't think, where is it? Yeah, I don't think Craig wrote all of these books, but that's okay. Maybe I'm wrong. Maybe you did write X.Docklet in action, and maybe I'm just not knowing that. But it gave me a list of strings back, right? It said 1 through 9. Here are the things. Now I could do the dance of trying to take this and convert this into objects, or I could say, hey, give me a list of JSON back. That's great, but it's still going to give me just a list of JSON strings back, right? It gives me the thing. Now I've got to try to tie this up to a record or something in my system. But Spring AI is going to help us do this. So what it does is we can create an output parser. This one is going to be the Bean output parser. We can give it our prompt, and we could say, hey, here's the author, and the format is actually going to be of a certain type. And what is that type? That is the author class, right? So we're saying, hey, take that string and convert it over to this author class. Now, to make this happen underneath the hood, Spring AI is basically communicating this to the LLM, saying, yes, not only do I want JSON back, but I want a very specific type of JSON back. And then under the hood, it will convert it over to this author class. So if I go ahead and rerun this, and I try to go to /API/books/by author. And the default will be our friend Ken Cousin. It should go ahead and list out an author. So now I have a type. I have a type where the author is this. There's a list of books. In this case, I think it's just a list of strings, but we could have done that. And now we have a list of books for Ken Cousin. So that's the output parser really kind of helping us out. Now I realize I am running up on time, so I'm going to fly through my last section here and maybe not go through a demo. But again, all of this code is up on the GitHub repo. So the AI can't know everything. Again, we've learned about LLMs and basically that they're working off of training data. This training data has a cutoff date, right? Like if you've ever used ChatGPT before and you ask it something after September of 2021, it goes, I don't know, or it may make something up. So there are techniques to solve this problem so you can kind of bring your own data. Again, we have limitations here. They're trained with public knowledge up to a certain date. They don't know anything about your private or corporate data. So how can we fix this? You could go in and fine tune models, but that is, again, more along the machine learning paradigm of this, and something that I'm not going to do as just a Java developer, right? Something else you can do is stuff the prompt. I want to add some data into the prompt that I send off to the LM so that it has some context to understand about the question I'm asking if it doesn't know the answer to. Another answer to this is something pretty new called Retrieval Augmented Generation, or RAG. And this is how we can retrieve relevant data based on the user input and adding our own context to it. There are many strategies for this, one of which is using embeddings and vector databases. So a simple example of this is stuffing the prompt. So I asked this question to a system. I said, what sports are being included in the 2024 Summer Olympics? So here's my system message, and it basically says, using the following pieces of context to answer the question at the end. If you don't know the answer, say, I'm sorry, I don't know the answer to this. Here's some context. Here's the question. So the first go around, when I asked the question, is I don't know the answer to that. The second go around, when I've added a list of sports to the context, I went in and filled that context. It knows how to answer that question now because I provided some context to the LLM. So that's one version of it. The other is retrieval augmented generation. And this has emerged to address the incorporating of relevant data into prompts for an accurate AI model. So it kind of looks like this. We have an inquiry. We asked our application that is talking to an LLM. Before we do so, we are going to look in a vector store. Now, we're not going to get into this today a lot, but at the end of the day, we could have, say, a bunch of documents about a certain product of ours that ChatGPT doesn't know about. We could take these documents, use embeddings to kind of split them up, store them in a vector store, store them in one of the many vector databases supported. And now what we're doing is augmenting the prompt because we don't want to send all the data of all our PDFs with it because we know now that tokens are the currency of LLM, right? So we don't want to send all this data and get all this data back. What we want to do is like say, hey, based on all that PDF data that I fed you, do you find anything similar or it's known what's known as a similarity search? Have you found anything similar? If you did, well, let's kind of stuff the prompt and send that along with it as we ask the LLM for this. So a whole bunch of vector stores, again, not just for text search. These are all implementations of the vector store interface. The example that I used in the code base is using the simple vector store. So go ahead and check that out. I wanted to get into those, but we will another day. Again, visit the YouTube channel. I'm going to kind of cover this in depth a little bit more. So references, the Spring AI reference documentation, again, really good. There's a really good lecture that I've gotten some of my intro stuff from on the Turing lectures. And it's called The Future of Generative AI. If you have about an hour and you're really interested in like learning more about some of the basics, awesome video to watch. Google has a free course out there on learning some of these basic terms and like how these things work. So go ahead and check out that course. And the Spring team, Mark Pollock, Craig Wells, Josh Long, they've all been creating content around Spring AI. So go ahead and check them out. So that's all I got. You can find me, dan.vega@broadcom.com, at the real Dan Vega on Twitter, and head over to danvega.dev. So with that, I'm going to jump back in and see if we have some questions. I'm sure we have a few.
So first of all, Dan, thank you so much. That was an amazing session. And while
Awesome.
I thank you, I'm requesting everyone who's watching to share their feedback via the QR code or the link that we have shared in the chat. It would be beneficial for us to figure out how we could improve in future. And with that said, Dan, you have to embrace yourself. Lots of questions.
All right. Well, we could just ask ChatGPT how I can improve myself.
That's a good one. That's a good one. Okay, so oh my God, I removed you instead of the slides. So now you're back, and
All
now
right.
I have to remove the slides. Okay, so first of all, a quick show of the comments, compliments, awesome talk.
Oh,
Thanks.
thank you.
Then great presentation.
Thank
That's a lot
you.
of love, and thanks a lot.
Aw.
Great talk. Another great talk. So thanks, Dan. Yes, and there's a lot of thank you coming in. So thank you so
Awesome.
much.
Thank
So
you all so much. I appreciate that. It was a lot of fun
and
putting this talk together. So
yes. So now for the questions. So there was multiple comments coming in, and I think you covered that as part of your session as well when you talk about prompt engineering and how to make sure that you are asking the right questions. So there was a lot of questions coming in, and folks mentioned that they don't like the kind of code that they receive from the large language models. They don't compile. One person said just 10% of the code compiles. So I know you've already kind of mentioned that, but quick thoughts.
yeah. So I'll say it really depends on what model you're using too, right? So we looked at there's a list of 570,000 models out there. You can always play with different models. It really does come down to like which model you're using. So maybe are you using an older version of GPT? I know GPT-4 is exponentially greater than GPT-3. So maybe that could be the case. It is insane. It really does come down to how you're crafting these prompts to the system. We don't get caught up in that because we go to ChatGPT and there's like a text input and we just say, well, tell me how to write Java code. And it just can't be like that. There is so much more like context that we have to give to the system. Like, you are a comedian. You're writing jokes. This is your audience. These are the types of jokes they care about. Like, it really does matter what we're prompting. And I will say, yeah, there are certain times where the output is not desirable. It is sometimes it's wrong. Sometimes it's blatantly wrong. But this is where us as developers have to test these out. Write your prompts. If you're not getting the desired output, let's start rewriting those or crafting those a little bit different. So I think that's the best place to start. I share in your frustration. I mean, all the answers are not always the greatest, but this is a work in progress. So
Absolutely. And the folks need to kind of reconsider the fact that they are asking a language model. So the code that they receive would not be compiled. So that has to be taken care by the
yep,
developers who are asking the questions.
yep,
So there's another question which says, are there copyright
fantastic
issues
question.
with AI generated issues? If I generate a quiz with AI, can I publish this online without fear of getting in trouble with any law?
I would say this is always something that you should take a look at yourself. So I know that open companies like OpenAI are constantly getting sued now and yelled at. The New York Times is basically saying, "Hey, don't include any of our content in there," because if you go ask like ChatGPT about something, you can clearly see that it came from the New York Times article, and they're not getting attribution for that. They're not getting credit for it, right? This is a huge, huge topic in this space, and it's really just started. I would say I use a lot of AI to so some of the things I use it for is like coming up with talk titles or summarizing a document. Anything I do not take whatever comes out of an LM verbatim. I always kind of try to make it my own, and I always proof everything. Like, is this? You're asking the question: is this going to get me in trouble with the law? If you think there's a chance of it, then yeah, don't use it. So yeah, it's something you definitely have to think about.
Makes sense. And if folks could kind of figure out the source, then they should probably ping them and seek their permission. That would make sense.
Yep.
Yeah. There were a lot of chatter in the chat about, let's say, if everyone is asking LLMs, what about websites
Yeah.
like Stack Overflow? So, what happens? How do they get the data then? Because if all the data is being used by uh, the models, so there were
Yeah.
a lot of chatter. So if you have any comments on
It's
this one.
it's a it's a very interesting question. I don't know the exact name of this study, but I heard a professor talking about a study that they did, I believe at Cambridge, and the study was around this same thing. It was like, all right, the model's been trained on all this data that we've basically provided it, all of our blog posts, all of our Stack Overflow questions. What if we start to take those away and only introduce things that are content that the AI itself generated? So now the AI is
Mm,
learning off of the code or the text that it generated. And what it found out is that it increasingly got worse to the point that
uh,
it started producing gibberish, right? So yes, the
mm,
LLMs are feeding off of the content on the internet. Without that, there is no LLM, right? We talked about it in the talk. The thing that has made these large language models and generative AI work is the vast amounts of data and the vast amounts of compute power. So if you take that away, then I don't know that you have an LM. So my guess is these companies are racing to the point where it can have these systems figure that out on their own before it gets to that point. But it's a really interesting question to think about.
And the next question is from John, and
Mm.
it was probably when you had a demo in your session.
Uh-huh.
So that was about how does it differ from LangChain 4J, especially because the library can also be integrated into Spring.
Yep. Just another way, it's the other library out there that makes working with LLM models. So LangChain 4J is modeled after LangChain, which is a popular one in the Python community. And it just goes about it
Mhm.
different. Yes, it can be used in Spring applications. I would say the advantage you have with going with Spring AI is we have, all the kind of Spring component models that we're used to working with. So if you're building Spring applications, the things that we looked at, like being able to integrate with prompts and have those output parsers and being able to automatically work with something like a vector database, there's auto configuration for all that stuff. So Spring just makes it easier to work with all those different things. But yeah, LangChain for J, if you're writing just Java applications, definitely a great library to check out.
The next question is about the prompt template or any feature in Spring AI. So, does that provide any securities or guards against prompt injection attacks?
That I don't know the question. I don't know where you would get a prompt injection. I think it's just a string template replacement, so I don't think it's executing anything else. But that's something I'd have to look into. I don't know the exact answer to that.
Okay. Probably they could use the string templates in Java, so the newest, but that's not a production feature yet. So, yeah.
Yeah, well, the one thing so when I say string template, I think this is something different from the Python community as far as like replacing that. The reason those templates are the way they are, so we wrote out like, hey, find me the most popular YouTubers in this genre, is there are entire communities out there where you can find prompt templates. And so these work with those same templates. So if you want to go look like in these different communities and say, hey, I'm trying to build an application that will do this, you'll see examples of really good prompts already. So after you're done kind of getting started, that's a really great place to learn and maybe get some inspiration. Like the same way that I would go look on those sites back in the day to like get an inspiration on how to build my new website, right? Like how it should look. This is similar. Like there are prompt template sites out there that can give you inspiration as what questions you should be asking the system.
Absolutely. So the question, the demo that you had, so that earned brownie points too. so this so this one's a long question, so you can take your pick and answer just one or two.
Spring Forward communication thread. Yes. So user messages, assistant messages, system messages are always sent to chat without manual keeping and tracking the whole context. So I think what you're asking is more of state, right? So REST APIs are stateless. When we send a message to chat to OpenAI to the LLM, we can't just send another message back and say, wait, give me 5 of those instead of 10 of those, because we can do that on ChatGPT's website, right? Because they are tracking state. So there's no way to currently do that. It's something we're looking at maybe for 1.0 release or later. But this is something you could implement yourself, right? You are basically saying, when you give me 10 YouTubers and their subscriber count in the Java world, then the next time that you send them a message, you have to include that as part of the request. Here's the thing I already asked you. So now I could say, wait, only give me 5 back. Now it has the context, the same way that we talked about, like kind of stuffing the prompt. It has the context. But this is something you got to be careful about, right? Because the more we kind of add to that we have to send to the LLM, those are tokens. That's costing us money. Again, maybe not a big deal if we're just kind of doing something on our local machine. But if this is something we put into the wild and we constantly keep building a cache of data that we're sending, then that could probably get pretty expensive quick.
Makes sense. So that's a compliment about the feature that you had on output parsing.
Nice.
And I think I will stop because a lot of questions, but I don't have the time because we're already over time now.
All
And
right. I will
okay,
give people an
so
avenue. So you can always
okay.
find me on Twitter. Also, spring office hours every Monday. Come there, ask your questions there, and we'll continue the conversation there. So,
Okay, so last comment, super talk.
thank you
And
so much.
and of course there are a lot of other comments also, similar comments. And thank you, Dan. It was such a pleasure to learn from you today. It was an
Oh,
amazing talk.
thank you
I
so
loved it.
much. I appreciate
And
it. Thanks for
before
having me here.
And just some housekeeping details. Anyone who's watching the session today, you could follow Dan and IntelliJ Idea using the social links that we have on our um, screen right now. And stay tuned for our next IntelliJ Idea live stream, where I would be talking about Java 22 and IntelliJ Idea
Yes.
on, yes, next month. The date is
Awesome.
still undecided, so we'll see you there. And
I've
until
seen
then,
all your I've seen all your articles on like Java 21 and
ah,
Java 22. They're great, so I'm looking forward to that talk.
thank you so much. Thank you so much. And now I'm scared and excited and nervous. So, everyone watching, thank you so much for joining us, for asking questions, for participating, listening, learning. I'm sure you loved the session the way I did today. Thank you so much. And thanks again, Dan. And until next time, bye bye.
Thanks, everyone.